Hi everyone. The question says a crate of mass 9.4 kilogram is pulled up a rough incline with an initial speed of 1.42 meters per second. Write these values down. The mass is 9.4. The initial velocity is 1.42. The pulling force is 102 newtons parallel to the incline, which makes an angle of 20.1 degrees with the horizontal. So here we go. We have a diagram of what is going on in this example. The object is being pulled through some displacement, right? The coefficient of friction is 0.4 and the crate is pulled 4.94 meters. The crate is being pulled how many meters, everybody? 4.94 meters. So this displacement here is 4.94 meters. How many forces do we have acting on the object? The gravitational force is pulling the object down. Force of friction is acting on the object, preventing the object from sliding. And another force is acting, what is that force? F pull, the force with which the object is being pulled upward. Make sure you write down all the given information, everybody. There is an initial speed involved. The initial speed is not zero. The initial speed is non-zero. The object is being pulled. Friction is acting on it. Gravity is acting on it. The angle of the incline is given to you. The coefficient of friction is given to you. Displacement is also given to you. Now have a look at the first part. How much work is being done by the gravitational force on the crate? Whenever I say to you the work being done, work is always force times the displacement. Would you agree? How come I'm not using the integral or here dx? Because the force is constant. Whenever the force is constant, you end up having this equation here. What kind of, right, so we're asked to calculate the work being done by the gravitational force. So we have to put down here the work being done by the gravitational force. What is gravitational force by definition? Gravitational force is mg times the delta x. Would you all agree, everybody? Very good. Now, what is wrong with this delta x here? Have a look. Take a look at the figure that's given to you. The object starts at this point here and it's being pulled on the inclined plane, correct? Very nice. Gravitational force is always perpendicular downward. Would you all agree? Good. So the question is asking you the work being done. In other words, what is this? What are you going to plug in for delta x? Are you going to plug in here delta x equal to 4.94? That's a given to you, delta x. No, everybody, you're gonna have to use the vertical displacement because the gravitational force is acting vertically. How can you solve for this here? Let's call that delta y. You're gonna complete yourself a triangle. The angle given to you is 20.1. The hypotenuse is given to you. The angle is given to you. How can you project the hypotenuse along the opposite side? How can you solve for delta y? It's going to be nothing more than the hypotenuse times sine of the angle because you're projecting the vector to the opposite side of the angle. Sine gives you the opposite side, right? Good. So the work being done by the gravitational force is force times the displacement. What is the force given to you? mg. What is the displacement? Delta x times sine of theta. And there is one more term here, the negative sign. What does that mean? The force of gravity is acting downward. Okay, so put everything together. Negative mg delta x times sine of the angle. This is how you find the work being done by the gravitational force. Now moving on to part B. Determine the increase in the internal energy of the crate incline system owing to friction. So when you rub your hands against each other, what happens? You are creating energy, heat, due to the fact that there's friction going on, right? Good. Now the question is asking you, find the increase in the internal energy as a result of the friction. Scroll down. Energy is being created due to what? Due to the force of friction. However, if you want to take the energy approach, you cannot just take the force, you have to take the work. The change in energy is equal to the work being done on the system. So now you're going to tell yourself there's a change in the internal energy. There's a change in the internal energy due to what? Due to the external work being done. What type of work are we talking about? The problem is telling you specifically force of friction. So now you put down work is equal to force of friction times the displacement. This is the definition of work. Mu times N times delta X, everybody. After all, force of friction is nothing more than mu times N times the delta X. Continue working. You have mu. What is the normal force? Now you have to go back to the diagram and you have to figure out what the normal force is. The normal force is not given to you by a specific equation. You have to figure it out. Normal force here. How many forces do we have acting? Normal force against the gravitational force. How can you find the normal force from the given two vectors? Here is going to be the projection of the gravitational force, right? That is perpendicular to the surface. How can you find a perpendicular component? W times what? Cosine of the angle. Here is the angle. Here is the vector. You are projecting the vector along the adjacent side, right? W times cosine of the angle. Mu times W times cosine of the angle times the displacement. Work being done is equal to the change in the internal energy. Carry on your multiplication and then you end up having 171 joules of increase in internal energy as a result of the force of friction. Next part. How much work is done? How much work is done by the 102 Newton force on the crate? Again, the question is asking you to calculate the work being done by the force, right? What is work by definition? Force times displacement. What is the total force acting? 102 newtons. What is the displacement? Multiply those two, you're going to end up having 504 joules. And there we go, our answers are consistent. Now, part D is difficult, so pay attention. What is the change in the kinetic energy of the crate? Guys, the problem involves, as you can see, work, correct? Good. And now it's telling you to calculate the change in the kinetic energy. So basically, you must calculate some form of kinetic energy, right? So that you can calculate the change in kinetic energy. We have only one equation that relates the work to kinetic energy. What is that equation? Whatever external work is being done is equal to the change in the total energy. When I say to you total energy, right? If you want to now get down to kinetic energy, you must write down what? The energy final minus the energy initial. How many forms of energy do we have? We have kinetic energy final plus potential energy final. Why? Because the object is moving vertically as well as it's moving along this parallel to this surface. Minus the kinetic energy initial plus the potential energy initial is equal to the total work being done. So let's scroll over. The question is asking you to calculate the change in kinetic energy. but you have a long way to go. You must first of all resort to the work being done is equal to the change in the total energy. What is the change in energy? Final kinetic plus final potential minus kinetic energy initial plus potential energy initial. Then you have to expand the definition, 1/2 mv f squared plus mgh final minus 1/2 mv initial square plus mgh initial. What are you going to put down on the left side of the equation? The net work being done. How many forces do you have acting along this horizontal line here that is causing the object to move? You have two forces, F pull, and working against that is the force of friction. What is the magnitude of F pull? 102. What is the force of friction? Mu times mg cosine theta. Then you have to multiply by delta x. On the right side of the equation, you have 1/2 mv final square, mgh final, 1/2 mv initial square, mgh initial. Now, what is the initial velocity? The problem has given you the initial velocity 1.42 meters per second. What is the initial height, everybody? You can always take your initial height to be 0. You can take that line that I showed you in red as the reference line to make your life easier. This line here take to be h equal to 0. What is the final height? What is the final height the object reaches? What is this change in height? You already calculated that from part A. It is delta x times sine theta. This final height here is delta x 4.94 times sine of the angle. What is it that is the missing part? What is it that's missing? The unknown, that's the final velocity. So from this entire equation, you have to figure out the final velocity. Once you figure out the final velocity, now you're gonna give me the answer for the change in kinetic energy. 1/2 mv final square minus 1/2 mv initial square. Where did you find the m final from? From this equation here. What was the initial velocity? The initial velocity is 1.42, and you get the idea. This is the best I can do. I'm sorry, I have my work to do as well. I'm working in a lab. What is the speed of the crate after being pulled 4.94 meters? Again, it's the same speed you're gonna find from the previous part, the final speed. Okay?